Hello everybody and welcome to Simplifying Trig Expressions Part 2. Let's pick up here where we left off. And what we did right before the last video ended was we replaced secant with 1 over cosine and tangent with sine over cosine. We multiplied these together and got sine squared beta over cosine side beta. And I mentioned that it seems like we're making this more complicated, but we actually made our lives easier. And here's why. If you look at this step, remember that you can go from 2 fractions to 1 fraction. And luckily for us, both of these fractions now have the same denominator. So we can make this into a single fraction with the denominator of cosine of beta. And the top would be 1 minus sine squared of beta. Now, if you're not convinced yet that this made it more simple, I want you to now notice that we have a squared term. And the Pythagorean identity is sine squared theta, or x, I'll use beta, plus cosine squared beta equals 1. If I get this identity in this format and I subtract the sine squared beta to the other side, I get that cosine squared beta is equal to 1 minus sine squared beta. Here I have that 1 minus sine squared beta, and I'm going to replace that with cosine squared beta over cosine of beta. And if I have 2 cosines on the top and 1 on bottom, I know that I'm left with just 1 cosine of beta. Another way you can think of that is this top is cosine of beta times another cosine of beta over cosine of beta, and 1 pair crosses out, so I'm just left with 1 cosine. So we got this to simplify down to 1 trig function. Look at that. I feel accomplished, don't you? Speaking of accomplished, let's take a look at this doozy of a last problem. It's sort of a challenge problem, but I think it's a good one to end on. So what this problem is doing is we are multiplying cosecant of x by this entire parenthesis. These 2 terms are multiplying and you're subtracting the sine of x. So we definitely could use some trig identities to start, but this is a time that actually I'm thinking maybe doing some distribution first may help us. So what if we distributed in the cosecant of x into both terms? So this first term would be cosecant of x times cosine cubed of x times tangent of x, and then it would be minus cosecant of x times sine of x. So all I did was distribute the cosecant in. The reason that I noticed to do that is I noticed that if I multiply this in, cosecant and sine are reciprocals. So what if I replaced cosecant with 1 over sine of x and I multiplied that by sine of x? What would happen over here is the sines would cross out, so this would just be minus 1. That's nice. Now let's look at the red part. Again, let's think about our quotient identities. Let's think about the reciprocal identities. I'm generally a person that likes to do sines and cosines if possible, so let's see what we can do from here. Cosine cubed is not an identity. It has to be squared to be Pythagorean. So what if we tried some tricks that we've already used? What if we replace this with 1 over sine of x? Let's for now keep the cosine cubed alone, and let's replace tangent with sine of x over cosine of x. If I do that, here's something that I notice. This sine of x crosses out with the 1 in the denominator. If I have 3 cosines on the top and 1 on the bottom, that means I'm left with 2 cosines, or cosine squared x, minus 1. Now I have a squared function. So for the 3rd time in this video, the Pythagorean identities are going to come and help us. Because again, I know that sine squared x plus cosine squared x equals 1. So let's see if we can manipulate this identity to become this. Cosine and 1 are on the same side. So let me subtract the cosine over and get sine squared x is equal to 1 minus cosine squared x. Does this match this yet? Not quite. It looks like the signs are different. What I mean by sign is S-I-G-N, the positive and negatives, not S-I-N-E. I know in this unit it gets confusing when I say sign of a number versus the trig function sign, so just be careful about that. So because these have different positive and negative signs, let's think about what number can I multiply both sides of an equation by to change the sign but not the actual problem? How about -1? If I multiply this side by -1 and multiply this side by -1, the identity becomes negative sine squared x equals, let's distribute the -1 in. So this would be a -1, and then negative times negative, positive cosine squared x. This could be rewritten as cosine squared x minus 1. These are the same because the cosine is positive, so it just needs to remain positive if moved in the front. So what I see now is that cosine squared x minus 1 is really the same as negative sine squared x. So this, yet again, reduced to a single trig function, this time negative sine squared x. All right, guys, thanks for sticking with me on the second video. I hope it was useful. Again, please feel free to redo any of these problems on your own. Trig identities is something that you need to practice as many times as possible. It's one thing watching me do it, and it's another one trying it on your own and see if you can get the same answer. So thanks for sticking with me. See you next time.